This lesson will be on tangents and normals. So far, we've found that when we find the derivative of a function, we get a new function which gives us a measure of the gradient of the tangent at different points on the curve. We're going to take that a step further and using that gradient actually find the equation of the tangent line. So let's have a look at this question here. Find the equation of the tangent to the curve y equals x cubed plus a half x squared at the point x equals 1. Now just to help you visualize what we're doing here, I've got a graph of this curve here. So y equals x cubed plus a half x squared. We're trying to find the equation of the tangent line to that curve at the point x equals 1. So I've added that tangent line in to our curve here at x equals 1. We're at about 1.5, y value of 1.5, but we're going to go ahead and find that y value soon. But what we're trying to do here is to find the equation of this tangent line. Now to find the equation of this tangent line, there's two things that we need. One of the things that we need is the gradient of the tangent line, and the second thing we need is the coordinates of this point here, where x equals 1. So why don't we go ahead and find the coordinates of this point here at x equals 1. So to do that, we can just substitute x equals 1 into our curve. Y will equal 1 cubed plus a half times 1 squared, which will equal 1 plus a half. So y equals 1.5 or y equals 3 over 2. So we know the coordinates of this point here on the graph, x equals 1, y equals 3 over 2. Alrighty, the next thing that will be helpful to get the equation of this tangent line is the gradient. Now this is the process that hopefully you're familiar with. To find the gradient of this tangent line, we need to take the derivative of the curve. So dy dx equals 3x squared plus x. The gradient of the tangent at x equals 1 will be the value of this derivative at x equals 1. So when x equals 1, dy dx equals 3 times 1 squared plus 1, which equals 4. So we're saying that the gradient here of this line is 4. Alrighty, so we've got enough information now to find the equation of that tangent line. Using the point gradient rule for finding the equation of the line, y minus y1 equals mx minus x1. We'll get y minus our y coordinate was 3 over 2 equals 4x minus 1. That was our x coordinate. Y minus 3 over 2 equals 4x minus 4. Let's make y the subject here. Y equals 4x minus 2.5. Let's make that minus 5 over 2. So the gradient of this tangent line here that I've added into the graph there is y equals 4x minus 5 over 2. Righty, let's have a look at one more question. This question is asking us to find the equation of the normal to the curve with the equation y equals x cubed minus 2x squared at the point 1, negative 1. Now, again, I've got a graph here of that curve. So we've got y equals x cubed minus 2x squared, and I think this will help you to visualize what's going on here. The normal line is the line that is perpendicular to the tangent line at a particular point. So for our question here, we're given the coordinates 1, negative 1, so I've marked that in there. If we were asked to find the equation of the tangent, the process would be identical to what we did in the previous question. We'd find the derivative and then find the value of the derivative at x equals 1. But if we're trying to go ahead and find the equation of the normal, we need to find the gradient of this normal line, and because it's perpendicular, we know that it is going to be the negative reciprocal. So if we have the gradient of the tangent equal to m, then the gradient of the normal will be, as I said, the negative reciprocal, so -1 on m. And hopefully that rings a bell from when we did linear relations earlier in the year. So let's go ahead and find the gradient of the tangent line. So again, to do that, we differentiate this equation here. So we'll get dy dx equals 3x squared minus 4x. When x equals 1, we get dy dx equals 3 times 1 squared minus 4 times 1, which equals 3 minus 4, which equals minus 1. So we know that the gradient of the tangent, so this line here, is -1. But we want the equation of the normal and therefore the gradient of the normal. So we can say, therefore, gradient of normal equals the negative reciprocal, so it's going to be -1 over -1, which equals 1. So the gradient of this normal line here is, I'll call it m1 equals 1. Now we can go ahead and find the equation of this normal line because we know this coordinate here that it goes through. That was given in the question, so we know it goes through 1, -1. In the previous question, we had to go ahead and find that y coordinate, but we're given it here. So using the point gradient form, we can find the equation. So y minus y1 equals m x minus x1, and I'll call this m1 just to make it clear that it's the normal. So let's make this m1. So we've got y minus, our y coordinate was -1. We got that in the question there. So y minus -1 equals, the gradient of our normal was 1. So x minus the x coordinate, which we had in the question, was 1. So we'll get y plus 1 equals x minus 1. Let's make y the subject. We get y equals x minus 2. So the equation of this normal line here is y equals x minus 2.